The carbon phases webinar will begin with a brief overview of the chemistry of the phase and the underlying zirconia particle. It will continue with some guidelines for use. The webinar will conclude by highlighting 3 of the most popular ZirChrom carb and diamond bond C18 applications. All ZirChrom phases are based on a zirconia particle. The crystalline structure of the zirconia particle has 7 bond valency when compared to silica's 4. The additional bonds in the crystalline structure of zirconia protect the structure from hydrolysis. The result of this unique configuration is a particle with superior stability and a unique surface chemistry. The surface of zirconia has 3 types of sites, all highly reproducible and homogeneous. There are Bronsted acid sites, Bronsted base sites, and a large population of Lewis acid sites on the surface of zirconia. For further information about the unique surface chemistry of zirconia, please click on the Technology Overview Chrome U webinar link that can be found on the Chrome U page of the ZirChrom website. Our ZirChrom carb phase is crafted by coating a zirconia particle with a very thin monolayer of elemental carbon. The resulting phase is flat, lacking a partitioning mode of separation, but allowing for enhanced shape selectivity of closely related compounds, especially where structural differences affect the pi-pi bonding between the compound and the phase. This column is particularly ideal for diastereomers and geometric isomers. Diamond bond C18 is the ZirChrom carb particle with a C18 moiety carbon-carbon bonded to the surface. The resulting particle retains much of the shape selectivity of a ZirChrom carb column and adds the sample loading benefit of partitioning chromatography. Using a ZirChrom carbon phase adds a wider array of tools to your method development toolbox. The ZirChrom carbon phases are both thermally and chemically stable. They are stable at temperatures of up to 200 degrees Celsius throughout the entire pH range and are compatible with a full range of organic solvents. The unique surface chemistry of the ZirChrom carbon phases allows for a multimodal selectivity of ionic compounds. The carbon phases have reverse phase, ion exchange, and pi-pi bond interactions. The selectivity of the ZirChrom carb phase is often observed to be orthogonal to that of the typical silica C18 column. In order to achieve optimum performance, special considerations must be made when selecting a mobile phase for a carbon phase. ZirChrom Technical Bulletin 293 covers these considerations in detail and is available at any time on the ZirChrom website. Here are some great examples of how the unique selectivity of ZirChrom carbon phases can be put to use. One of the most popular applications for the ZirChrom carbon phases is the analysis of structurally similar compounds. When one of our customers needed to quantify 9 structurally similar N-nitrosamines in pharmaceutical packaging, they turned to ZirChrom for assistance in developing an approach. Collaborative efforts led to the development and validation of the LC-MS-MS method shown in Technical Bulletin 295. These chromatographic conditions capitalize on the unique temperature stability and surface chemistry of the diamond bond C18 phase to achieve baseline resolution of the compounds in less than 13 minutes. ZirChrom carbon phases are well suited to the analysis of steroids. Technical Bulletin 266 details the analysis of 6 structurally similar sulfate steroid conjugates. The unique selectivity and thermal stability of ZirChrom carb enables baseline resolution of this challenging sample in less than 5 minutes. Small polar molecules such as acrylamide and acrylic acid can be difficult if not impossible to retain and separate on conventional silica C18 phases. Technical Bulletin 281 is an excellent example of how the additional tools in the zirconia method development toolbox can be used to overcome the toughest separation challenges. Using temperature, extreme pH, and the unique surface chemistry of ZirChrom carb, a fast separation of acrylamide and acrylic acid was achieved using a 4-minute gradient. These application notes can be found on the ZirChrom website at www.zirchrom.com. Thank you for completing this Chrome U webinar. On the ZirChrom website, you can access our full Chrome U webinar series, use our free Buffer Wizard tool, or learn more about ZirChrom products and applications.